Hello everyone, and welcome back to All Things Space. After spending 3 years winding its way by planets and gradually traveling towards our closest star, NASA's Parker Solar Probe has finally reached the Sun's atmosphere. Just as landing on the Moon allowed space experts to understand its origin, touching the Sun will help scientists uncover critical information about entities like the solar surface, the solar atmosphere, solar wind, and how they're impacting life on Earth. But how exactly did the Parker Solar Probe achieve this groundbreaking milestone? And what shocking discoveries did it make about solar activity and its effect on our planet? NASA's Parker Solar Probe has touched the Sun. Here's everything you need to know. Number 6. What is NASA's Parker Solar Probe? Parker Solar Probe is part of NASA's Living with the Star program to explore aspects of the Sun-Earth system that directly affect life on Earth and provide us with the closest ever observation of a star. Back in 2018, NASA launched the probe to unlock the mysteries of the Sun's atmosphere, to help scientists make better predictions about space weather and understand solar outbursts that can interfere with life on Earth. Later, in December 2021, during a press conference at the American Geophysical Union Fall Meeting in New Orleans, NASA officially announced that the Parker Solar Probe had become the first ever spacecraft in history to touch the Sun. Parker's Solar Probe touching the Sun is a monumental moment for solar science and a truly remarkable feat, said Thomas Zurbuchen, the Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. Not only does this milestone provide us with deeper insights into our Sun's evolution and its impacts on our solar system, but everything we learn about our own star also teaches us more about stars in the rest of the universe. The Parker Solar Probe achieved the historical feat in April 2021, when it was about 8.1 million miles away from the Sun. Facing brutal heat and radiation conditions, the spacecraft managed to get inside the outermost part of the Sun's atmosphere, or the corona, which brings us to the next question. How exactly did Parker touch the Sun? Number 5. What does it mean to touch the Sun? Before answering this question, it's crucial to understand the structure of the Sun, which is the only star humans can study up close. Unlike our planet, the Sun isn't a solid sphere, but it does have a zone where the immense gravity of the star keeps in the solar material it spews through fusion. In simple words, the Sun is an enormous ball of insanely hot, largely ionized gases, mainly hydrogen and helium, with trace amounts of carbon, neon, oxygen, and nitrogen. The Sun is so colossal that it could fit over 109 Earth-like planets across its diameter, which also means it has enough volume to hold around 1.3 million Earths. It does have one similarity with our planet though. Just like the Earth and other solar entities, the Sun is made up of multiple layers, all of which are drastically different, but still play a collective role in producing and transmitting the energy that the Sun ultimately emits. The innermost layer is known as the Sun's core, which contributes to 20% of its mass. The core is extremely dense and the center of all of its energy. Energy is generated within the core via thermonuclear reactions, creating extreme temperatures that can reach as high as 15 million degrees C, making it the hottest part of the Sun. The second layer is known as the radiative zone, a region that starts at about 25% of the distance of the solar surface, and extends up to about 70% of the way to the surface. The energy generated in the core slowly moves outward, taking more than 170,000 years to radiate through this layer, hence the name radiation zone. Then comes the convection zone, which forms the outermost layer of the Sun's interior. As the name indicates, this is where solar energy continues to move toward the surface through convection currents. Next comes the visible surface of the Sun, or the Sun's atmosphere, which comprises 3 layers: the photosphere, the chromosphere, and finally, the all-important corona. The photosphere, which means sphere of light, is the innermost layer of the solar atmosphere, where most of its energy, in the form of both heat and light, is emitted. It reportedly takes around 8 minutes for sunlight to travel from the photosphere to the Earth. The next layer in the solar atmosphere is the chromosphere, a relatively thin layer that's sculpted by magnetic field lines that restrain the electrical charged solar plasma. It's called chromosphere, or colored sphere, because this layer is composed of hot gases emitting light at discrete wavelengths, thus creating a spectrum of bright emission lines, or red streaks, that are often visible during eclipses. Number 4. What is the solar corona? Finally, let's talk about the solar corona, which can be best described as the outermost part of the Sun's atmosphere, When it comes to exploring various solar aspects, this layer is particularly crucial because ionized elements within the corona glow in the X-ray and extreme ultraviolet wavelengths, which is why the solar corona can emit nearly half as much light as the moon. When we say NASA's Parker Solar Probe was able to touch the sun, what it essentially means is that the probe successfully managed to get inside the corona. In doing so, the spacecraft also crossed the much-anticipated boundary known as the Alfvén surface. It's the point that marks the end of the sun's atmosphere, and scientists had not been able to measure exactly where it was until now. Number 3. How did Parker survive the sun? Why didn't the Parker Solar Probe simply melt in front of the sun? How was it able to withstand such insanely high temperatures, not to mention solar winds? For starters, the spacecraft is protected from the sun by a 4.5-inch thick carbon composite heat shield, allowing it to withstand temperatures outside the spacecraft that soar to 1,377 degrees C. The solar probe is also smart and extremely efficient, thanks to an autonomy software that allows the probe to remain cool on its own without any human intervention. Parker is also equipped with solar limb sensors on its external surface that allow it to travel in the right direction and automatically sense whether or not the heat shield is in the right place. There's also an internal cooling system that keeps circulating water behind the radiators to prevent the solar cells from overheating. Number 2. What did Parker discover? According to NASA's official statement, the Parker Solar Probe flew within a record-breaking 3.8 million miles of the sun's surface, with its 4 instrument suites designed to study magnetic fields, plasma, and energetic particles, and the origin of solar winds. The spacecraft's trajectory took it into the corona for nearly 5 hours, going as low as 15 solar radii from the sun's surface. In that zone, Parker discovered a pseudostreamer of electrically charged material, which is one of the enormous structures that are visible from Earth during total solar eclipses. Passing through the pseudostreamer was like flying into the eye of a storm, NASA said in the same statement, adding that Parker sensed conditions inside the pseudostreamer were quieter than the roiling environment outside of it. Moreover, the spacecraft also studied unusual zigzag-shaped structures found in the magnetic field of the solar winds, known as switchbacks. Although switchbacks were first discovered over 2 decades ago, Parker's data has only recently found their likely origin and impact. According to the probe's findings, switchbacks originate from supergranules in the photosphere, occurring in patches and having a higher percentage of helium than other solar components. This newfound information is revolutionary in solar physics, which will, in turn, help people on Earth to prepare for disruptive space weather, such as solar storms that can knock out satellite communication. Number 1. What's next for the Parker Solar Probe? NASA's solar probe is just getting started, aiming to make a total of 24 close passes of the sun. Parker is expected to fly within 3.83 million miles of the sun's surface by 2024. However, the mission's closest approach is scheduled for 2025, when NASA's Parker Solar Probe will be only 6.2 million kilometers from the solar surface. That's it for today, guys. If you enjoyed this video, don't forget to give it a thumbs up, subscribe to the channel, and ring the bell icon to stay notified about our latest uploads. We'll see you soon. Until then, take care and goodbye.